Have you ever pondered how a computer can solve a Sudoku puzzle, or how a GPS navigates the quickest route to your destination? These seemingly different tasks have something fundamental in common. They both involve solving problems within a set of constraints. This is where the concept of Constraint Satisfaction Problem, or CSP, comes into play in the realm of artificial intelligence. In broad strokes, a CSP is a mathematical problem defined by a set of objects. However, these aren't your everyday objects. These are objects whose state must adhere to certain conditions, restrictions, or as we call them, constraints. Whether it's ensuring that no two adjacent regions on a map share the same color, or that no two queens share the same row, column, or diagonal in a chess problem, CSPs are all about finding a solution that satisfies these constraints. So, at its most basic, the constraint satisfaction problem in AI is about finding a solution within a set of constraints. Now that we've got a grip on what CSP is, let's delve into its components. The Constraint Satisfaction Problem, or CSP, is primarily composed of three crucial elements: variables, domains, and constraints. These are the building blocks of any CSP, and understanding them is key to understanding how these problems are solved. Let's start with variables. Picture variables as things that can take on different values. For instance, in a Sudoku puzzle, each cell would be a variable. It's a place where a number can be assigned. Now let's move on to domains. If variables are the placeholders, then domains are the set of possible values that these variables can take. In our Sudoku example, the domain would be the numbers 1 to 9, as these are the only values that can fill each cell. Lastly, we have constraints. Constraints are the rules that restrict the values that variables can take. They are the laws of the problem that cannot be broken. In Sudoku, a constraint might be that no number can appear more than once in a row, column, or square. These three components, variables, domains, and constraints, form the backbone of any constraint satisfaction problem. They outline the problem space, define the rules of the game, and limit the possible solutions. But why is understanding these components so important? Well, by understanding the variables, we can identify what needs to be assigned. By understanding the domains, we know what options we have for each assignment. And by understanding the constraints, we can eliminate options that violate the rules, narrowing down the search for solutions. So, in essence, understanding these components is like understanding the rules of a complex game. Once you know what pieces you have, where they can go, and what moves are allowed, you're well on your way to finding a solution. Understanding these components is crucial to understanding how CSPs are solved. You may now wonder, how does AI solve these constraint satisfaction problems, or CSPs? Well, it starts with defining the problem, which involves setting the variables, the domain, and the constraints. Then, the AI begins to explore the potential solutions. This exploration is not haphazard, but rather, it's guided by sophisticated algorithms, each designed to address different types of problems and constraints. Some algorithms might use a trial-and-error approach, known as backtracking, while others might use more advanced techniques like forward-checking or constraint propagation. These methods help the AI to efficiently navigate the problem space, avoiding unnecessary steps and reducing computational load. However, it's important to remember that solving CSPs can be a complex and computationally intensive task. It's akin to finding a needle in a haystack, but the needle can only be found by following a specific set of rules. It is through this rigorous process that AI can solve complex problems, from Sudoku puzzles to route navigation. Let's take a step back and consolidate what we've learned about CSP and AI. The Constraint Satisfaction Problem, or CSP, is a mathematical question defined as a set of objects whose state must meet several restrictions or constraints. It's a vital concept in artificial intelligence, enabling systems to solve complex problems efficiently. We've also delved into the components of CSP, including variables, domains, and constraints themselves. Variables are the unknowns we're trying to figure out. Domains are the possible values these variables can have, and constraints are the rules defining which combinations of values are valid. Artificial intelligence uses sophisticated algorithms to solve CSPs. It systematically explores the problem space, looking for solutions that satisfy all constraints. CSP is critical in numerous applications of AI, from scheduling tasks to mapping routes, solving puzzles to optimizing resources. The next time you marvel at AI's problem-solving prowess, remember the humble constraint satisfaction problem, the powerhouse behind it all.